what we want to look at now is what happens when the parabola is not at the vertex is not at the origin for this parabola. So parabolas can move around any way they like. So what we want to have a look at is a situation where our vertex is at HK, and that means our focus would move as well. It means our directrix would be moving. Remember, we've always got a distance of A between our vertex and our focus, and distance of A between the vertex and the directrix. So that doesn't change. That's still going to be the value of A. So parabola here has a vertex at the point HK. It's getting up with this equation. This is the equation you've got to remember. It's very similar to the idea when the circle has the center not at the origin. We're using that idea of HK again as the center of the vertex, or as was before, the center of the circle. So HK is that vertex there. The proof, have a look at the proof. It's, as we said in class, it was long and complicated, but what we've got to have the idea is that we're going a distance from P to S, which is from the point that's on the parabola to the focus. L is the point on the directrix again. So we're going to say that if that's going to be the case, by the definition of a parabola, the point on the parabola is equidistant from a focus, a fixed point, and the directrix, which is a fixed line. So in this case, we're going to have the distance formula on PS, which is a square root, x minus the h squared plus y minus the k plus a, which is the hk in this case, because hk is the vertex, so k plus a is the focus of the parabola. So, and then it's going to equal to y plus k minus a. Now it's the distance from the point P directly straight down to the directrix, so it's going to be that equation. So what we do is we square both sides, because that allows us to get rid of the square root, but it means that the right hand side gets squared. Now what we've got to do is expand this whole thing out. Now this is where it's got to be done with care. X minus h becomes x squared minus 2hx plus h squared. Then the y minus k plus a all squared gives us the expansion here. So y squared, 2 times the y times the k plus a. The last term, k plus a, is all squared. Similarly, on the right hand side, we do the same thing, except this was y plus k minus a. So our brackets are k minus a instead of k plus a, and we have the plus there. So again, expand our quadratic here and our brackets on this side, and we get all these terms. Now the nice thing about this, it looks a little bit hard, but what we can start to do is play around and start cancelling terms, because our y squareds are going to cancel. So we get a y squared cancelling with the y squared here. We also get a k squared cancelling over both sides. We get an a squared cancelling on both sides there. Now we can, I think we can cancel, no, we can cancel a 2ya as well. That starts to cancel out as well. Now what we can do is add some terms across. So we get add 2yk across, and add the 2ak as well, or subtract the 2ak. So we start to get terms together. And then we start getting this expression, which allows us to get back to this expression. Now what we've done, we've gone back and factorised those. We want to get back factorised to the 4a and y minus k. And that's what we've been able to do there. So there's the expression. We don't have to remember the proof, but we do need to be able to remember this result. So let's have a look at some examples with this in. So just before we do that, be aware that the equation, if it's on its side, would be y minus k and x minus h there. So the y minus k would square and be 4a times the x minus h. So it swaps, the x and y swap around again, like we saw with the generic example where that vertex was at the origin. Here's some examples of what they look like. So you've got x is equal to a function there. Okay, and we can manipulate that back into the form we want to get the vertex and the origin. Oh, that was nasty, sorry about that. So let's have a look at an example here. We want to find the equation of the parabola where the focus is 0, 6, directrix has that equation y is equal to 0. So if that's the case, you plot those up. Our vertex this time is at 0, 6, so there's our vertex. Our directrix is at y is equal to 2. So it's actually on the x-axis this time. It's not below the x-axis. It actually is the x-axis. Now remember, we want to get our equation in this form. X minus h equals 4ay minus k. We're told that the focus is 0, 6 up here. Our vertex must be right in the middle again of our vertex and our focus. Sorry, our focus and our directrix. So what we do is we put find the focal length. I know the distance from between the focus and the directrix is 6. So I divide it in 2 because the vertex is at the midpoint there. So that's going to give me a focal length of 3. And that's what I've done, just done the y value of the midpoint. So the vertex is going to be 0, 3. So because it's halfway between them. So if that's the case, now I've got h and k from there. I know a is 3. I'm able to do the substitution, and there's the expansion, or not the expansion, the cleaning up of it. We don't need to expand this side because it's x minus 0. And I'm just going to leave it in that form. It still allows me to see that my vertex is 0, 3, and my focal length would be 3. And then I can go do anything else with it that I want to, and solve any other problems. If the focus is 1, 5, the vertex is 1, 2. So what we've got to realise is that on our parabolas there, we've got the vertex being 1, 2, focus is 1, 5. Again, we've got HK. What we need is A. We know the distance there is A, and if that's at 1, 5, we know A is going to be equal to 3. So we've just solved that there. We've subbed those values in. The 1, 2, sorry, that should be. There's 1, 2. So that gives us the 12 outside of y minus 2, and it's x minus 1 in that situation. Again, vertex is minus 3, 1, and the directrix has an equation of y is equal to minus 5. So there's y is equal to minus 5, because that's our axis there. And the vertex is at minus 3, 1. So the vertex is there. That's v at minus at 1. Our focal length is going to be 6. And that's where we get our focal length from. Because the distance from the vertex to the directrix must be 6. So putting it into the form, x minus 3, which gives us the x plus 3. Notice that it's minus 3 there, so it becomes a plus in that situation. And 4 times 6, which is the focal length, times the y minus 1, gives the x cubed, x squared, x plus 3 all squared, and 24 outside of y minus 1. Indeed, this time the vertex is 2, 3. Axis is parallel to the y-axis and passes through the point 5, 4. If you draw this up, have a look. We've got a vertex at 2, 3. So vertex is at 2, 3. Its axis is parallel to the y-axis, so it's going through there. We've missed the point a little bit, but that's okay. And our parabola then goes up. And it passes through the point 5, 4. So this one's a little bit trickier. But again, if we know that we can set up this form, because that's the vertex, 2, 3, we need to find A, but if it passes through the point 5, 4, that means 5 and 4 can be substituted in, and it must satisfy that equation. That allows us to get an equation just with A in there, which allows us to find what A is. Now we can put A in, 4's will cancel, and that gives us the 9 in that situation. So what we need to do is just use the data that we're given, realize that we can put a value, we'll put those values of 5, 4 in because it is solving that equation. In E, this time the focus is 2 minus 1. Directrix has the equation y is equal to 3. So this time our focus, here's our focus down here, 2, 1. 2 minus 1. So our focus again is below our directrix. Okay, we know our focal length is going to be half the distance between the focus and the directrix. So that gives us a focus of 2. So if we go up 2, there, that we can see it's two units that way, 2 units that way. So that's our vertex. Our vertex must be at 2, 1. Okay, and also our vertex, our parabola must be concave down. because the focus is below the directrix. So there we go, what the focal length is. We know what H and K are, so we can substitute. It's going to be -8 in this case because it's going to be concave down. We should have a minus in there to start off with. We got it in at the end but not there.